Suppose we have a system that accepts x as input and its corresponding output is y. So the output of that LTI system and its input and system impulse response are related by a mathematical operation called convolution. So y of t, the output, is given by x of t input convoluted with h of t impulse response. So we need to know what is an LTI system, what is convolution and impulse response. So let's start with LTI system. LTI means linear time invariant system. So it has two properties. They are linearity and time invariance. So let's start with linearity. So linearity again has two properties, additive and homogeneous. A system is said to be linear if it satisfies both these properties. So suppose we have a system and for x1 input, when we pass through the system, we are getting corresponding output as y1. And when we have x2 input, when we pass through the system, we will have y2 as the corresponding output. So for x1 it's y1, for x2 it's y2. When we superimpose the input signals x1 plus x2, if we get the superimposed individual output signals, then obviously the system is said to be additive. Let's go to homogeneous. So suppose we have a x as input and we are having corresponding output as y. If we scale the input with a, so we have ax, then if we have ay, then the system is said to be homogeneous. So combining these two ideas, a system which is additive and homogeneous is said to be linear. So we have ax1 plus bx2. When we pass through the system, we have ay1 plus by2. Suppose, let's see, we have a input x and correspondingly y. If we again give x, so x superimposed with x, we have y superimposed with y if it is a linear system. So it means obviously for 2x it's 2y. So does additivity always imply homogeneity? Think of it. Let's come to the idea of convolution. So the idea of convolution is like, so we will express any input signal in terms of a basic signal, so that we have a summation of time shifted basic signals, time shifted and scaled basic signals. For that basic signal only we will study the system's response. Because it is a linear time invariant system, the output will be a simple summation that is time shifted. Let's understand time invariance. So if we have a time invariant system, it doesn't vary with time. So if we give x input, it's y output. If we shift the input by capital T, the output will also be shifted by capital T. It doesn't care about time horizon. Let's understand impulse response. If we have a system, we give impulse as input to the system and the corresponding output is called impulse response of the system, usually denoted with h of t. So unit impulse signal is like, we have one unit value at 0, everywhere else it's 0. So let's see representation of signal using impulse so that we get a better idea. So del of n, the scaling factor is 1.35, means the amplitude is 1.35. If we say 1.35 del of n minus 2, which means it will be shifted to 2. So it will be 1.35 height at 2, everywhere else it's 0. So we have a continuous signal. Let's discretize it. We only take the values at 1, 2, 3. So now you can see at 1 we have sine of 1 value height impulse. And at 2 we have sine of 2 impulse shifted at 2. So it is sine of 2 del of n minus 2, sine of 3 del of n minus 3. So that square bracket is the right representation. So this is simple summation. And if you think, you might think like we have sine signal on the right side, but that sine of k is a constant value. So any signal x of n can be represented as a scaled and shifted impulse. Summation of that scaled and shifted impulses. So let's say we have an LTI system. So here we are coming to the crux of the idea of convolution. So this x of n can be represented as a constant scaling and time shifting. So x of 0 is a value del of n, x of 1 del of n minus 1, x of 2 del of n minus 2. Of course we have the negative indices also, x of minus 1 del of n minus 1, which is n plus 1. So let's say we have this. So because we know that for del of n we have the h of n as impulse response and x of 0 is just a scaling factor, we will have x of 0 h of n, because this LTI is a homogeneous system. And because it's additive and time invariant, and we can just get x of 1 is a scaling factor. For del of n minus 1, the response will be h of n minus 1, because this is a time invariant system. So because this is an LTI system, this can be represented as a scaled and shifted summation.